Let's explore the AND operation, or the AND logic gate. So with an AND gate, AND is one of the three basic gates that all logic circuits are made out of. And in the AND operation, the output X is only going to be 1 if all of the inputs are 1. So we can draw what the logic gate looks like. So here we're going to draw the logic gate called AND. The AND logic gate, we're going to explore what the AND truth table looks like. The AND, excuse me while I fumble with my video, truth table. And then we're going to look at the AND expression, or Boolean expression. Okay, we're going to do this for the OR gate and the NOT. So those are the three basic gates that all logic is built in out of. So the logic gate, so logic gates are a way that we can draw these expressions. We can draw this logic. And as we get more and more complex, we can draw entire digital circuits based on combinations of these gates. So this is how we draw a gate. This gate, for an AND, I like to put the word AND inside it so I'm extra sure. Some people draw it a little bit messy and they might draw it like this. Well, that actually looks more like an or they'll go like this, and that's actually an AND. So I like to put the word AND inside so that if I'm being messy, I can still tell what logic gate that is. I'd like you to do the same so that I can mark your midterm and your final properly. So it has some inputs, A and B, and the X is the output of the AND gate. So if I were to write a Boolean expression for this, the output X is equal to A and B. So this expression is read, output X is equal to A and B. It's not A times B. It's a Boolean expression, means and, not multiplication. Or often we shortcut and we say A, B. And again, that's not multiplication. It means A and B. So this means A and B, not multiplication. All right, so now we've written down the Boolean expression. We've shown what this logic gate looks like if we were to draw it. So let's make a truth table. Remember, a truth table is a table that shows us what the output would be depending on the input. I see that this has input A and B, and it has output X. Well, I said that the output X is only high if all of the inputs are high. So let's look at the combination of inputs. There are 2 to the n inputs, where n equals 2. So there are 2 squared inputs, which equals 4 inputs in this truth table. If there are 4 inputs, then I cut it in half, and I say half of them are zeros, half of them are ones, 0, 1, 0, 1. So those are my possible combinations of inputs. Now the outputs are only going to be high or true if all inputs are high. So here, all inputs. All inputs are high. Therefore, the output must be a 1. All other combinations must be 0 because not all inputs are high. Oh, hi, here. So that's my truth table for an AND gate. I need you to look at this truth table and be able to memorize that combination of inputs and outputs. But you do it by remembering that an AND logic gate works such that there is only a high output X when all of the inputs are high.